I'll just get the ball started. We're a bit early, so people will be coming in. So, hey everybody, my name is Joel. This talk is k8s, my k8s, setting sail with Spinnaker. Before I start, how many people know what Spinnaker is in this room? It's gonna be great. It's gonna be awesome. Cool. And there's a little hidden gem in this too with Istio, so we'll talk on that too. So a little bit about myself. I do have a sword, so that's just me there. I'm the manager of Cloud DevOps at Redbox, formerly at GoGo. That's my Twitter handle if you want to follow me on there. In addition, I'm also a GDG organizer, so I run Google Developer Group meetups here in the city as well. Don't have to tell you much about Redbox. How many people in the room use our services today? Cool. Thank you for being customers. We really appreciate your business. So we have our kiosks where you can go and rent discs and also video games as well. I should also ask, how many people know we have a streaming platform? Look at that. Oh, look at that. That's pretty good. You guys won the most hands up for any time I mentioned this to anybody, so congratulations. Which is good. That means we're doing something right. So Redbox On Demand launched about a year and a half ago. It's our streaming platform. It's coming to latest TVs like Vizio and other TVs as well. We're also on mobile apps, and we're also streaming via the web as well. So, streaming. This is a distributed problem, right? With kiosks, you can typically put discs, and there's a lot of complexities that go into that. With streaming, you can be coming from any edge of the world, or really any edge of the country specific. You could be sourcing out of California. We really needed something to handle that extra amount of traffic. And we turned to the cloud for that. So various solutions in Google Cloud, Amazon Web Services, and ultimately leveraging things like containers and Kubernetes to help deliver that. So to start, I'm just going to give a quick brief history of computing based on popularity. So we'll start off with, we have VMs versus containers, serverless versus Kubernetes. How did we get here? Like, what are all these things? Where do I put my services? There's a lot of great use cases for each of these technologies, but where do they kind of fall? So bare metal, at the end of the day, just a basic server. You can install anything you want on there, one operating system, one server, great for dedicated workloads. In fact, they're still used today. They do serve their purpose. However, when you start talking about microservices, what happens when you have unexpected failure, right? What happens if you get unexpected traffic? I mean, these are physical servers. They're expensive, right? You're not just going to have a closet of servers available to you, or at least I would hope not. Up until recently, it was pretty hard to automate, right? There was no real solidified way up until recently around things like config management. We'll touch on that in a bit. But this basically, everything went down, and you had to go back to racking and stacking, which, it's a very manual effort. So let's solve hardware failure. Income virtual machines. Install hypervisor, you guys run some apps, you can run multiple OSs. Great. One server can run multiple VMs. It's going to be awesome. You have distributed workloads. This one could be running your front end, this could be running your back end. Hopefully you have replicas of that. And it's a little bit easier to automate the system level. This is typically where you start seeing automation at the operating system level. So, hey, we need a new VM. You can click a button, PowerShell, whatever you want to do, spin up a server, no problem. The cons, again, now we're no longer delayed. We're now delayed by the OS boot time, right? If I have to handle that extra load, that means I have to boot up an OS. Nowadays it's probably minutes, but it could have been a little bit longer than that. How do you handle unexpected traffic spikes? Again, you still have the same problem. Well, you need to have more servers. When you have 100,000 users in your system, you're probably running at capacity, but I guarantee probably at 3 in the morning, no one's hitting it, and those servers are just sitting there running, collecting electricity bill, just doing nothing. It's expensive, and it's hard to automate now at the application level. So this is now when we start talking things like the .NET frameworks, Jetty, Tomcat, application servers. At this point in history is where the config management wave started to come in. You typically see things like Puppet and Chef and Ansible and these giant playbooks to essentially do deployments. They're great. They're great to establish a state of your running VMs, but at the end of the day, you still had to account for the heavy weight of the OS, the aspect of the operating system into the picture. So, weather update. We have capacity on demand, the cloud, right? What are you running in? Amazon? Azure, Google Cloud, that other one that I'm not going to name, or else I'll get sued. Um, pros, you fast on-demand scaling, right? You click a button, you get 3 servers. You want 50? Go ahead and make 50. Everything's driven typically through an API, which is great from a development perspective. And on-demand costs, I mean, frankly, are relatively cheap in the grand scale of things. Cons, you lose a lot of visibility, right? Nothing like being able to say, all right, this is how this network is actually established, how these wires all connect. You kind of lose that visibility, and you have to put a lot of trust in your providers that they're doing what they say they're doing. This is great, but initially, when the cloud came out, you're still limited by boot times. At this point in time, compute was relatively, straightforward. You just kind of click an instance, you get it. No longer were you kind of doing deployments on the same running server. You kind of shifted to this cattle, not pets mentality. You give your pets a name, Spiky or Fluffy or whatever. When a server is served this purpose, you just create another one, shift your workloads over, and shift traffic over to it and destroy the old one. No longer do you have to keep these static IPs and knowing what these boxes. Typically, you always refer to these as static IPs. So new server, new deployment. And the benefit of this is that your application rollouts and your operating system now are homogeneous. They're the same, right? The same way you do your application rollouts, they kind of go through the same pipeline, and there's no real way to kind of differentiate from that. So, we're still limited by OS boots. You still have to boot operating systems. So this is kind of where containers came into the picture, and I'm not really going to touch on what a container is. There's a lot of better speakers out there, but at the end of the day, in a file, you find what you want. Run these steps, creates me an image, very similar to an ISO, though very, very different. You execute a command, you give it a tag, it creates you an image, and you can run that image. Docker run this, and now I have an application running on my server. I shifted the dependency of that application now to a separate image that can be deployed and replicated to the needs of my business. So again, now we shifted to the operating system having multiple containers. So no longer are you delayed by these OS boot times, now you're just delayed by how fast can I spin up my container. Containers are, for those that don't know, very, very lightweight. Some are very large, but we're talking megabytes. Some even being in some of the larger projects being in the gigabytes, but generally speaking, anything over 25 megs is a little bit large in terms of a container size. And the best part is, everything's well defined, and the way you can build that code is now, again, a series of steps that can be reproduced. I like to sum this phase up in a few things, but you're still dependent on the VM, so if your VM runs out of resources, Docker is not going to magically spin up RAM. You can't download more RAM, right? At least not yet, I don't know. There's no well-defined orchestration at this point in time. And it was a little bit harder to debug, so now you have to think about it as, okay, I have a hardware which has a VM running on it, which has a container running on it. How do I get logs up that to something that I can see, I can debug, right? For all its faults, this is kind of the phrase where I said that I said it worked locally, it can no longer be used, right? That's it. If you have a container that runs locally, ideally it should run remotely. So let's solve that server problem and turn serverless, right? This whole wave of serverless, and this is kind of where we are, I think, a little bit today. Pros, it's functions as a service. When writing software, typically you have a lot of functions. You kind of break down and just run those small functions instead of running your whole entire application. Great. You only get charged for the time that function is running, which is awesome. And they're fast and lightweight. And you also just eliminated the server overhead, at least from your perspective. There's still servers, again, as we touched on earlier. The cons. Well, last I checked, I can't run AWS Lambda in my data center. I am going to be vendor locked in. Lately, there's been the trend with things like Knative and serverless framework. You should look at those if you want to kind of avoid jump on the serverless bandwagon, but not get onto the vendor lock-in bandwagon, I guess. It's great for simple one-off functions. You could totally architect a microservice with serverless They're great in presentations. Wait till you actually have to debug them. They're very distributed. They're very hard to get those logs, especially locally. It's still kind of a developing area. All right, this is the part where you're just like, this is boring. Where's the Kubernetes? So don't worry. Let's solve container orchestration. So Kubernetes, what is it? It's an open source container orchestration system. It handles your application deployments, being in containers. It's very important that it's container based. It handles your application scaling to meet the needs based on some criteria, and we'll touch on that. It's also service and node management. It also can maintain a distributed cluster. It was originally designed at Google, and it was maintained by the CNCF. If you've heard of it, it's the Cloud Native Computing Foundation. There's some really cool projects that come out of that foundation. So, many look towards Kubernetes to solve all these problems. Improve reliability and rollouts, faster scaling and load balancing, centralized config management and secrets, granular service communication, and better monitoring between your containers and apps. So, I don't know about y'all, but my LinkedIn feed just buzzed with all these vendors saying, look, we're Kubernetes native now, just sprinkling Kubernetes into the name. You know, I think most titles of these apps are now k8s native service. And I think that's kind of like what the sales pitch is right now. What's the problem? You know, we should just do Kubernetes for everything. So you have to ask why Kubernetes. There's a lot that goes into it, and we'll touch on that. It can solve all the problems I talked about earlier, if it's implemented correctly. It won't solve your fundamental cultural and work issues. You can't just say, oh, we're Kubernetes developers, do Kubernetes, we're DevOps now. No, very similar to that concept. It's not. You're going to have a bad time. It can be complex to understand. It can be very hard to troubleshoot. And if you're not using a managed service, it can be very hard to maintain and keep running. Hopefully you caught the talk earlier about digital transformation. I'm not going to go too much into that, but Robert did a great job covering digital transformation. So, at a high level, this is easy. Nodes, a master, API, what else? Oh, image registry, okay fine, I'll pay someone to do that for me. I'll pay Google, I'll pay a factory, not a big deal. What's so complex about this picture? Well, it's not just one mystery box. There's a lot of aspects of this that have to kind of work in tandem. So with Kubernetes, the API server is basically what performs your cluster operations. When you submit a request to Kubernetes, when you're running the command kubectl do something, this is typically where your request goes to. etc.d, etcd. This is a centralized key value store, and we'll touch on it. It's a very important thing about that too. It stores your configs for your cluster configuration, as well as the work that has to be distributed across that cluster. Kube scheduler, it basically looks for when I got a request and I make new pods, where do I put this work? Oh, this should go to node 1, this should go to node 2. And then a bunch of controller managers to basically maintain the other aspects of Kubernetes. I'm not going to go into it, but there's typically the 4 that you hear are node, replication, endpoint, and token. So what's a Kubernetes node? Again, going back to the picture, we now have a request coming into the cluster. Master figures out how to create that container-based workload, and it distributes it. Well, a node is basically composed of 3 things. You're running Docker, so it needs some container runtime, that being Docker in this case. Kubelet is essentially an API. It's basically what the API on the master interfaces with on the worker node, as well as kube proxy. This is typically when you're doing your Kubernetes 101 of how to expose these services on a node. When you say expose this service, it'll port forward, essentially, for lack of a better term, that request from that node down into your container. Work is by default distributed a little bit evenly, so around your cluster. So if you want 3 pods, it'll deploy it into 3 environments. But essentially, in that picture right there, there's 4 different applications, and they can also have volumes as well. We'll touch on that in a second too. So hopefully that picture, and I haven't even really dived deep into this, answers the question that if you don't have to run the server, you should not run the server. It's a very complex process. I put Google Cloud because It's literally one command. G-Cloud container clusters create stage, and I'm done. I automated all that toil behind the scenes of how do I make sure that this service is always running and always has enough memory to handle all these requests. It's all done for you. It's great. If you're not in Google Cloud, there's AKS. There's also EKS. Pick something. It doesn't have to be Google Cloud, but I would really strongly encourage you to not go down the managed path, the unmanaged path, if you don't have to. So, Kubernetes is declarative by default. What's declarative? What do you mean by declarative? Everything is defined. It kind of goes back to the principles of DevOps, that if it can be defined, it can be automated, right? Anything that can be well-defined can be automated. In this case, it's YAML. It's, for better or worse, what they use in Kubernetes. You define important metadata. That's kind of defined up there. In this case, a name being Nginx deployment. You can call it whatever you want. Labels are just tags. They're just like, hey, app equals this, foo equals that, deployer equals Joel, right? These are just this little metadata. Replicas, again, as we're kind of transitioning into this, is just copies of your running application. I want 3 of them. I want 3 Nginx containers, essentially, I guess, in this simple example. Declare what image to use. In our case, I want to run Nginx 1.79, which you probably should have run because these slides are a little bit old. Look whatever the newest version of Nginx is. And ultimately, define how you want to reach your application. I want to expose port 80 to the world. These files are typically committed into source in a source repository. So that's kind of the lay of the land in terms of just a declarative nature of it. So at this point in the talk, I did a lot of high-level and even just a little bit low-level explanations within Kubernetes. The first thing you have to understand is, what is a pod? I said pod a few times now. A pod is the smallest resource you can get in Kubernetes. It is a collection of containers. The way I always like to explain to people is a pod of whales. A pod of whales is multiple whales running in tandem. It could be, well, there can't be one, but in this case, you can have a pod of 1 container, a pod of container, and a volume being very much like a hard disk drive volume that's persistent. You can have 2 containers in that volume, or you can have a whole cluster of them. At the end of the day, it's 1 or more clusters in a pod. That's the most basic aspect of Kubernetes. When talking about how people interface with pods, they don't typically create pods, they create deployments which create pods. And that is the file that we kind of went over it. Essentially, this is the most common interface. You define a deployment, you say an image, and you put all these things, and this ensures that your pods are restarted on failure. So if a service doesn't start up, you'll restart it. It also kind of tries to keep your deployments healthy with 2 things, a liveness and a readiness probe, and I'll touch on that in a little bit. But in short, to visualize that, we have this health diagram. So you define a deployment called my app, and I want 3 replicas of that. That request goes into Kubernetes into something called a replication controller. But for all intents and purposes, it's a replica set. And what that will do is create 3 pods of Nginx. 1, 2, 3, and distribute it evenly, again, by default. This is kind of the picture that we have here. So if you go through any Kubernetes tutorial, the next thing you'll typically run into is a Kubernetes service. So a Kubernetes service is essentially a logical boundary around pods based on metadata. Metadata is extremely important within Kubernetes. In this example here, the service is Nginx, which selects apps of type Nginx, and essentially draws this little perimeter. You can kind of see it on the right over here. It's called app B in this case, but service A just wraps service A. The most important thing is that this gets spanned across nodes, and this is what Kubernetes does best, is handling that load balancing of your requests across these nodes. A single IP with a singular service. Not only that, but Kubernetes can also do rolling deployments. How does this look? Essentially, Very similar to the immutable infrastructure. Create a new pod. You still have your 2 old ones running. Another one comes up. Make sure that it passes. And ultimately, the third one comes up in this picture. Going back, at this point in the pipeline, or in the deployment, there's 2 important aspects, and we touched on it earlier, are the readiness probes and liveness probes. Readiness probes are my pods ready? Are my pods booted up? Are they ready to take traffic? Typically, if this doesn't work, Kubernetes doesn't just halts the deployment. It says like, nope, I'm not gonna even try. I can't even boot up the container. I'm running into a bunch of errors. Liveness probe, on the other hand, are more for the persistence of that instance, of that pod, of am I alive, essentially? Can I still send a request to port 80? Can I still hit the /foo URL and get a successful response? Two very similar things, but very, very different, and used in different aspects of Kubernetes. Config maps. So Kubernetes also offers configurations built in based on environment variables or also files. You're able to create config maps, is the term for them, and essentially you can define, in this case, environment variables. So we say the log level should be info, and default price should be $100. And you can then reference that in your deployment YAML that you saw earlier, and say the environment variables inside my pods are log level, default price, value from, config map. There's currently an issue of sorts where if you change it, it won't change on your running containers. You have to kind of restart them. That's documented here. But for most people, it's kind of a static config file you can treat it as. Secrets. This is an interesting aspect of Kubernetes. So within Kubernetes, there's support for secrets objects. By default, your secrets, when you insert them, have to be base64 encoded, right? Encoded is not encrypted. Encoded is not encrypted. If there's one thing you walk away with, encoded is not encrypted. Base64 decoded, if you share that in base64 encoded string across your org, consider that secret blown out of the water. Anyone has access to it. You can decrypt it with the same inverse of this command that I'm sharing at the top. So make sure you keep your secrets, hopefully not committed first. Kubernetes does offer some aspects to this to help improve this. You can use cluster level encryption. So you can encrypt your etcd database, your key value store, with a hardware token or whatever you need to do to make sure you can enable it. It's like a flag when you're creating your cluster. Google Cloud actually, back in April, whenever Cloud Next, they also enabled application layer secrets encryption. So you can actually encrypt down to the application level, essentially making sure that other apps can't talk to that key store, essentially ensuring that those secrets are, in fact, secrets. You should look that up if you are interested in that. Another problem, pod autoscaling. How do you scale your deployments? Well, it's as simple as one command. kubectl autoscale my deployment at Nginx. I want a minimum of 2, I want a maximum of 5, and you should autoscale when my CPU reaches 50%. That one command essentially handles autoscaling based on metrics. Kubernetes itself is very metrics driven. It has metrics within the cluster itself, so it can generate basic metrics such as CPU, memory, network, and use that data to help scale and grow your cluster deployments. And this is just a picture of what it would look like. You issue that command, goes to the API server, the horizontal pod autoscaler, it just issues it, and essentially your pods just go ahead and check against that. So for, I guess, stateful workloads, Google Cloud also offers vertical scaling. Not everything can scale at horizontal layer. Like, for example, I would not envision an SAP server would be fun to scale horizontally. I think that sounds very, very painful just even thinking about it. So typically you have to say, hey, I only had 96 gigs of RAM, I need 128. Google Cloud offers that through vertical pod autoscaling. In addition to this, the nodes that I talked about earlier are for all intents and purposes, seen as workers, places where your containers can run, right? Google Cloud also offers node auto-scaling. If your cluster only has 96 gigs of RAM, right? You deploy 100 applications, each app uses 1 gig, you're committed over by 4 gigs. Google Cloud is smart enough, based on your metrics that you set, to scale and add additional worker nodes, which is, for lack of a better term, to scale and handle that workload as well. In your cluster, you get service discovery built in. No longer do you have to kind of run your own service discovery. You get a basic service discovery that essentially mimics DNS. You can call, instead of having to call the IP of your pods, you can just call curl nginx, and it should just work within that Kubernetes cluster. You can supplement this, however, with things like Envoy and Istio, and we'll touch on that for sure in a little bit. Crank it up a little bit. But the story's not done there. So typically you can run a Kubernetes cluster over in California. You can run anywhere you want, any cloud provider, any zone. With Google Cloud, you're also able to have a singular IP through any k8s, and have your requests routed to either, in this case, Singapore or California, right? And it'll know which way to go. Using a service called Traffic Director, integrates with that service mesh that we briefly touched on, and we'll touch on more in detail. And it's able to handle request routing in that picture there. So in this case, the Singapore, it looks like the shopping cart service is dead in California. So we're going to just go to Asia Pac and run our service. It's better to get a transaction than just have the customer error out and say, you're bad, you failed, right? The customer should not care about our implementation details of how we route the request. So that's it. We got Kubernetes. We got a command, put some pods, put some deployments, copy some YAML. We're done, right? So let's recap. We had a big laundry list of items to solve. So what did Kubernetes solve? We went into this effort with improved and more reliable deployment rollouts. Did it solve that? Well, let's see. We have deployments objects, and those make sure that our pods are created to spec. It's good. Rolling updates based on probes, based on health checks. Awesome. That's great. What did it solve? What if I have a complex deployment? This is just one service that I was just showing here. What if I have a cluster of 3 deployments? How do I handle the very different workloads? What if it's a front end, a back end, and a middle tier, right? How do I do canary testing? Do we just always go straight to prod and just whack the cluster and say, oh, whoops, sorry, customer, you couldn't rent a movie today because we're testing our Kubernetes pods, right? Where's the testing? And all this YAML and stuff, it just seems like we just have a bunch of text files, for lack of a better term, and just dumping it into Kubernetes. So that's still something to be fixed. Configuration secrets management. Well, we got both of them. So we have config maps for our configuration files. We have secrets objects for our secret store. What did we solve? So we touched on it earlier. You still need config management. You don't get away from it. You still need something to generate those config files for you. There's things like Ansible, Puppet, whatever. Do something to generate that. How do you isolate those secrets down to the level? You're still going to need something like KMS or Vault, especially in a cloud environment. Again, I showed you the issue of encoding versus encryption. You still need to figure that story out of how do I restrict these secrets so only the apps that need that secret get access to that secret. Service availability. You know what? They did a pretty good job with this. I don't have any complaints as of right now, but you can horizontally scale, you can vertically scale, you can scale your nodes if you run out of resources. Okay, pretty fair. Kubernetes solved that pretty well. Load balancing. Basic service discovery, which is just essentially DNS. You can enhance this with things like the GLB, as I showed earlier, with the Google Cloud Load Balancer and stuff like that, but still, that's needs to be improved. What didn't it solve? Granular service communication. I want to implement rate limiting. What does that mean? That usually means I have to phone up a developer and say, hey, can you write a custom rate limiting, or hopefully we all have to band together and write a custom layer of rate limiting across our cluster. What about encryption in the cluster? I mean, it's 2019. Encryption should be everywhere. We shouldn't be settling for HTTP anywhere in the stack. Anyone who argues that, oh, HTTPS adds latency, that's a load of hooey. There's other things you can implement that will make your code faster. Load balancing outside of the round robin. What if I want to route based on a cookie at a header? Right? I don't want just a round robin. I don't want to hit it once or two, 1, 2, 3, 1, 2, 3. I want to go to a specific deployment. Metrics and monitoring. Great. CPU, memory. What does this mean for me? I'm a developer. I care about it, but I want to know how my code is actually performing. I want custom metrics. I want to know how many requests per second I can handle. Why did that API call fail? I don't have an answer for that. I just have CPU, memory. I can kind of see spikes and kind of make inferences, but still. So you kind of ended up with this. It's a brand new boat. It's actually a really nice boat. It's nice and polished. You kind of right in there, but you still are kind of just waiting in the water. What are you doing? So let's solve those problems with an awesome tool called Istio. I really, really love this tool. So what is Istio? Istio is an open source service mesh that you can lay on top and just use it to distribute for your applications. It's a platform that you can integrate and have any logging, telemetry, and policy system implemented. It does all that for you. And also provides a uniform way to secure, connect, and monitor your microservices. So that's kind of the Wikipedia thing. So let's actually see it in action. In short, Istio provides 3 things, and it does it really well. Security, connectivity and routing, and observability. Across your distributed microservices, this is no longer a .NET thing. This is no longer a Java thing. This is just, my company has a wide range of languages that we support. I can implement a language-independent way of handling all 3 of these things. So, security. How does it do this? You can enable strong authentication and authorization, and I'll show this in the picture. So things like OIDC and JOT. You can implement JOT tokens into this as well. You can also implement RBAC, role-based access controls. This service can only talk to this service and not service B. And mutual TLS across your entire cluster. SSL certs on an edge is great. If you ever, typically where a lot of these diagrams fall apart is when you start talking about in the PCI zone, I guess is what you always hear. It's like, oh no, that's the private zone. There's no way that anyone can get in there, right? This is typically where that aspect comes into play. Did I mention that you get all 3 of these things without writing a single line of code? So how does this look? Istio, through using Envoy, offers an ingress proxy. So this is how requests come into your cluster. You can secure that with OIDC open up, as well as TLS. In your ingress proxy, that's where you have your rules. /foo goes to this, /var goes to that. Think of it as much like a gateway, even though it's not really an API gateway. That proxy communicates via MTLS to the service A in this example. Istio is really kind of on the bottom and a little bit into this application stack. Essentially, when a container comes up and a pod comes up, it'll instantiate the certificate and ensure that certificate gets auto-generated on your deployment. You don't have to no longer provision it, put it in the key store, restart the service, and hope for the best. This is all automated for you. You get metrics into Mixer, so this is where your logging and monitoring come into play. As well as with Pilot, this is where your routing policies come into play, like the request, this is unable to go to here. Service A can talk to Service B in this example. It's a very basic example, but this scales to essentially your multiple microservice architecture, as well as controlling your egress. Once you're in the cluster, you can limit what you can talk to. So you can say like, well, we trust Google APIs because we're Google Cloud. We don't trust joelvasella.com. I trust it, but I don't think anyone else should. You can also secure that layer as well. Handling that all for you out of the box, using essentially a service proxy. The one thing to take away from this diagram is you don't see service A calling service B. Instead, you see service A calling a proxy, which then enables that call for you. And you'll see why that's really important later. Istio has connectivity and routing support. So what does this mean? You can control your traffic management. You can now layer that down to specific requests. So you can do things like A/B tests, gradually roll out your services, or even canary releases, and we'll actually demo that in a second too. Failure recovery. Istio can proxy failures, actually. So if your service is down, it'll actually back off those calls and actually add a delay. There's no point in hammering a service that's already at capacity. Istio is smart enough to determine that, hey, this service is already kind of giving me a lot of 500s. I'm going to start backing off requests, not killing them, but still handle them at the proxy layer, which is great, which means developers don't have to write this complex retry logic. You can handle it for you. Fault injection. Istio also enables fault injection. You can enable faults to test before a customer sees what happens if I toss at 500? What happens if I turn up the latency to 500 milliseconds? How does my service respond? Again, all without custom code or custom libraries. So a quick example, this is a YAML file. Lovely, lovely YAML. So in this request, we'll start at the HTTP line. We're going to say match any incoming header with the username exactly equal to Joel. Route it to version 2. Otherwise, go to version 1. And how does this look in the picture? Requests go into the same gateway. They're not two different records. Joel isn't called Istio Gateway 2. We've talked to the same gateway. Based on that request parameter, Istio is smart enough to say, oh, well, this person doesn't have that header, so I'm just going to send them to the default route. I'm just going to send them to version 1. Me, Joel, maybe I'm quality testing my application, I'll always be routed to version 2. So essentially, I'm running in the same environment as my version 1 containers, but enabled to test version 2, which is actually pretty wicked. And we'll actually demo that in a second too. And finally, observability. It's kind of a weird aspect of Istio. You're probably wondering, like, well, how can Istio show me observable metrics? Well, keep this in mind. Istio is now handling all your service-to-service communication. So what does that mean? Istio can generate metrics based on latency, traffic, saturation, and errors. You can generate trace requests, distributed trace requests of this call coming into the cluster, going to service A, going to service B, going to service C, failing, and now you're able to see that entire flow of that one request throughout your entire cluster. Something that's very difficult to do, especially in a microservices architecture. And logs. You get granularity of source destination of those requests. You get it mainly for debugging, but you can also do it for audit logging as well. Like, well, why did that user get added to that database? You can trace that whole request and say, well, here's why. Again, the thing to take away from this is all without code. I didn't have to write a single line. I had to run a single command to install it. So at this point, you're kind of like this. You're kind of looking at your sail and just floating along. Even a managed cluster needs to be managed. So in this case, this individual upgraded to GKE 1.13. No problem. It's a single click. They advertise it. Single click upgrades. Well, guess what? Istio broke. And all the things behind it decided to break. And that's where Kelsey Hightower goes, even a Kubernetes cluster must be managed. You're still responsible for your third-party dependencies. You don't lose sight of that. So keep that in mind. So along with that, I have a few helpful tools that are kind of essentially Kubernetes tools on steroids. K8s, it's a terminal UI to interact and manage your Kubernetes cluster. If you haven't seen it, essentially it saves you time from having to remember abstract kubectl commands. So you don't have to do kubectl, get pods or anything. You kind of get a nice view that looks like this. Much nicer. You can also see your logs, as well as shell into your containers as well through the GUI, or through the terminal here too, which is pretty cool. Helm, typically you see Helm tossed a lot in Kubernetes land. It's essentially the simplest way to try out a Kubernetes service. I say try out because I have a love-hate relationship with Helm. It makes things extremely easy to install things. If I want to install Redis, Helm install values, stable Redis. I got Redis in my cluster. I'm done. How? Like when you do this one command, sure you'll get an IP when stuff breaks. Yeah, I just ran a Helm command. I don't really know how to debug this. I just kind of have to hope for the best here. There are definitely advanced concepts with Helm. I'm not knocking it, but I think that it still needs to be very. You have to have a mature understanding of Helm to effectively use it, especially at production scale. Customize. It's a KISS approach, a keep it simple, stupid approach to creating manifests. Bunch of YAML files. It's great. A lot of people are falling asleep to YAML files. I'm tired of YAML files. Developers should not be caring about YAML files. They should be caring about their code. However, that being said, there are cases where developers may want to override YAML files. Maybe the default in the organization is I only want one pod for every deployment. But I'm deploying a highly available application and must have 5 of them. So this is where you give the opportunity to developers to specify I want 5. And essentially it takes the base, takes a patch, lays it on top, and ultimately that's what goes out to the world. It creates these template files for you. You should definitely check it out if you haven't already. k8s is essentially, it's just fantastic. This is kind of where I have to break on this deal. It's great, but when you're debugging stuff, nothing sucks more than having to look at log files and kind of determining, it's essentially looking like at a giant TCP dump. Running in your shell, and unless you have like supervision, you kind of can lose things. We're humans, right? We're visual learners. So that's where k8s does something like this. Generates your request flow. You can see live requests. If more requests come, they run faster. When latency starts coming in, you'll see things go red. And we'll touch on that later. So we're done, right? Done. We got Istio, we got everything. We solved all our development problems. We're done. So let's look at it. Developer gives a YAML file, or whoever, apply it. Get your pod. Okay, you know what? It's Monday. I get it. People coming in from work on the weekends. You want to apply all these YAML files. Usually at this point is where you start running away. It's just YAML. It is way too much YAML. All right, you're just like, okay, this is it. I'm just like over this. We need to have automation. There has to be a better way because this is really what it'll feel like. Especially if you run it in this fashion. So let's solve this with Spinnaker and Kubernetes. So a little bit about Spinnaker. It was originally a Netflix open source project. It supports things like AWS, Google Cloud, OpenStack, even Oracle Cloud. Google themselves actually contributed support for GCP and Kubernetes, which is who started the project, as well as advanced canary analysis, and if we have time, we get to show that too. It was also recently added to the CD Foundation. Essentially, the CD Foundation is a continuous delivery foundation of the CNCF for continuous delivery. This is a tool that has been established, people trust it, people are implementing it at the enterprise level. Something essentially to kind of give you confidence that this is on the right path of tools. So what is it? It's called software delivery pipelines. I like to think of it as business process pipelines. It's a GUI around what does it take to get code from my laptop all the way to production at company A or whatever it may be. So a generalized pipeline in this case, we have a bake, which creates your image and your deployment. You have a checkpoint, which says, do you want to deploy this to stage? Yes or no. It's literally a click of a button. Generates your infrastructure. And from there, you can also deploy, do automated testing, and generate the precious change requests of things changing in a running system. It's multi-cloud. We talked on it, but this is an example. Top is a Kubernetes cluster running in Google Cloud. Bottom is an application running in AWS. It can manage both applications in one view. No longer do you have to go to, Concourse is really the deployment tool for Google Cloud, and I guess we have Jenkins for AWS, and I guess someone's trying Argo CD, but it's like, this is essentially one-stop shop for your continuous delivery. It's not easy. It's a pretty complex architecture, and there's a great documentation around each of these services. But as a whole, using Kubernetes and Spinnaker actually makes a lot of this a lot easier to maintain. So it's not like you just kind of run it. It's definitely something you should consider though when you're evaluating Spinnaker. So what's the workflow? And I'll actually demo this. Developers commit code, at least I hope. This is a Git repository that triggers a Jenkins build. This is the typical DevOps landscape today. That Docker container gets pushed to a registry. Spinnaker says, hey, look, there's a new image. Time to get prepared for deployment. And Spinnaker figures out the magic behind the deployment aspect there to your Kubernetes cluster. So, live demos. This is the nervous part for me. Live demos, there's a little disclaimer, the demo might not work and a bunch of other legalese, so let's hope that this demo actually works. The Wi-Fi is still working, which is great. So I'm just going to add a Hello Chicago Cloud Conference. I can tell you. Added the most important message. Push. Pushing out to Git. Let's take a look at that service actually running in production today. Well, I call it production. We have it running, saying hello production, and if I go to /greet, it's saying hello world. Reloading here. I'm going to cheat, and I'm going to trigger this job because I don't want to wait for the build triggers to pick up. Impressive, it picked up too. I'm going to go into Spinnaker now. This is essentially the view of Spinnaker and what most developers are presented with, especially at Redbox. You have a list of pipelines. Those pipelines have an execution step process. And in this case, the first thing that we do is we have, while the Spinnaker pipeline finishes up, we have a canary judgment phase, which essentially waits for a yes or no. A stage that does our Istio configuration files for that deployment in Canary. Handles that actual Canary deployment. And then ultimately getting this change out to production. How do we get that? And then also repeating the same steps. So if I see here, the build's almost done. Oh, Python, I love you, but sometimes you're a little bit blooded. Let's see, while we're waiting for that, I guess I'll also show. Spinnaker also has not only a delivery view, it also has a view into your infrastructure. So again, here's viewing all our Kubernetes clusters for this application. There's quite a bit of them because we're developing against this right now. But it offers ability to also roll back software too. You can move a clickable button. I want to roll back to version 7 from version 8. I can give a reason why. Because I said so. If I click this button, it'll roll back. I don't want to roll it back because I think someone's developing against this right now. In addition, it gives you a singular view into all your load balancers, as well as a view into all your firewalls. So, this build finish yet. No. This is running in the cloud. I'll come back to that. So while that's running, because the build process is going to take some time. So, don't get knocked off your boat. But what I mean by that is, when deploying with Spinnaker, it's great that you can run fast. It's nothing without your metrics. And Robert alluded to this earlier. You're going to have metrics, especially at the layer of Kubernetes, because everything's distributed. The cluster's in Singapore. It's also in California. You also have one in the EU. You also have one running in the East region as well, right? It's a distributed problem. The days of logging into your pods and getting logs are far gone, and I'm sorry to say that. I was the first person to say that. You need time series data. So to us, we look at things like Prometheus and Grafana. Prometheus being where the metrics are actually published to. Grafana being the visualization layer. Logs, that's where Elasticsearch is our database for our logs. Kibana is the visualization of that. Open tracing, the distributed tracing that I showed earlier. Jaeger is kind of more on the code level. Istio has Kiali for the service routing, which I showed earlier. Logs are extremely expensive. Talk to anyone from Sumo Logic. So you need to make sure you have a sophisticated log strategy. Otherwise, you're going to be paying a log vendor a ton of cash. Don't just log everything in debug. I know it's easy. I know it's tempting. It's great. But your infrastructure people will be very happy if you don't do that. So look at something like Elasticsearch for that. I touched on it earlier, but with distributed tracing, you're able to now then go from the service level view that we touched on earlier, but with something like Jaeger, go into the actual code itself. Here we see a call to the products page, which gets product details, which ultimately calls back to Redis, and we're able to determine that, well, it looks like Redis timed out, and that's why that one request failed, right? And it's able to generate a report. In addition, it's able to show these requests across the service diagrams as well. All in all, you need a solid metric strategy, which enables teams to perform more advanced analysis on your application rollouts, especially if you don't have developers running kubectl and having all these things locally. You need to give the developer something. So how does this look? Hopefully, see if Spinnaker picked it up. Hey, there it is. Cool. So I'm going to go ahead and continue this deployment. I went ahead and clicked OK. When you go to this deployment step, you're able to see that Joel was the one who clicked the OK button at this exact time. What is actually applying right now is essentially establishing my canary. I'm going to stop this future deployment too, because this is nuts. My canary routes have been set up. We're actually performing the Kubernetes deployments. The nice thing is that it actually shows the YAML files as well. So you can actually see what was applied. This is the lovely, lovely YAML. As you can see, it gets very complex. I hope no one has to ever write something complex like this, manually at least. And it's actually performing a deployment. It's in yellow state because we're just slowly spinning up the pods. Pods take some time to spin up. In my case, I should have done a Golang container, but this is a Python Flask application. So let's see. If I call, I'm still calling production. So if you recall, I said that you have to set a canary header. So there's a great plugin in your browser. It's called mod header. You can actually set the request header. It's actually kind of tiny. You can actually set the request header. In my case, I'm saying X redbox version values canary. If I zoom out, hello from canary. Further than that, I can refresh the greeting and say hello Chicago Cloud, right? I guess I forgot to hit save on the cloud conference part. If I remove this header, all my customers are still going back to hello world. So again, this is all without writing any custom layer logic in code. There's no if condition in my to handle these headers. These are all done with an Istio handling these two deployments, right? So with that, the reason why metrics are important is because you can layer on advanced canary analysis. What do we mean by advanced canary analysis? When you canary a service, you don't want to canary and compare metrics against a running system that has been running in production for like 7 days or whatever longer. The reason being, it's pretty common, a fresh boot of your service, especially in the JVM world, will have a completely different memory profile than a service that has just booted up, right? If you allocate 512 megs to your service, a brand new service is going to still have 512 megs. When comparing against the production stack, that server might have been running, it might be more like 256 with garbage collection, and you might see spikes and other stuff. Instead, consider the concept of spinning up a copy of production called the baseline and comparing that against your canary to get more accurate metrics when you compare those two. And ultimately generate a canary analysis report. I didn't get to demo it for the sake of time, but Spinnaker has a support for automated canary analysis. And in fact, I'll actually show up old reports so you can kind of see how it looks. But essentially, based on a few values and metrics, you can generate a score for your deployments automatically. There's no room for interpretation here. This is physical metrics. Is this canary better or worse at CPU? Is this canary better or worse at error request handling? Can I handle more TCP requests? There's no point in deploying a service if all these go up. You're just going to keep going down and down and down. So, a quick view into this. Thank you. Spinnaker handles a canary report here, as you can see here. It keeps them for historical purposes, for comparison, but you're actually able to see that my baseline performed worse than my canary. My canary almost returned 0 error codes. It looks like it returned I don't know, 3. However, my back end, my baseline returned almost 23. These are actual physical dots on the metrics. With that, Spinnaker was able to calculate a score of 100%. That, hey, this is 100% better. You're definitely, we're not talking marginal, you basically in 2x your performance on this deployment. That's why your metrics are extremely important. So if I go back to present, so if you implemented everything up until now, you're kind of setting the sails, you're riding the waves, you're spinnakering the seas. However, this is kind of where the DevOps aspect comes into play. You have to build a paved road. And I couldn't think of a nautical theme, so I just called it the paved road. I couldn't think of the paved ocean. I don't think that works. So what do I mean by a paved road? At Redbox, the cloud DevOps team, we build compelling solutions for our developers. We're very much an engineering team. The things that we do in our day-to-day is actually writing software implementations for our customers, I call them our customers, our internal developers. We treat them as our customers, just as our developers treat the external world as our customers. This is for all aspects of the cloud. In addition to that, we create flexible build pipelines for specific application needs. We aim to make deployments boring. Deployment should not be this grand event where you're all like, all right, it's Thursday, let's all get in the room and order pizza and make a deployment and enjoy it, woo! No, it's not. That's kind of not how you do things. Invest in a common deployment tooling. Have automated testing. Invest in your metrics. Get fast feedback after each deployment. Adopt the mindset of deploying many small changes instead of waiting for these giant release trains of, well, the search feature is going out on Tuesday. Make incremental change. Make those small changes and prepare for that. It's a lot to take in, but if you do this, you can deliver faster. Leverage things like Canary and A/B testing, as I alluded to. But most importantly, make your deployments a click of a button. I deployed to production just now with clicking yes once, and all the magic behind the scenes was done. Don't have your application deployments draw more focus in the actual change that you're delivering to the customers. So my team just generates pipelines, right? That's what we do. No, it's all done through code. There's no centralized ops team for the cloud. All those deployments that you just saw are handled by developers. Developers are empowered to push to production whenever they need. They can make change whenever they need. There's no silos, there's no release trains, there's no giant Jira cards linking them together. It's all coordinated together and figuring this out. Instead, developers are granted with quality, SRE, and DevOps working in harmony to kind of deliver this solidified aspect of the pipeline. As you saw, there was a quality step in our pipeline. That's a developer working hand in hand with our quality engineers. There's an infrastructure step. That's our infrastructure, and there's also the monitoring and the metrics. That's where SRE comes into play. So what does this all mean? We don't write YAML. This is not the part where we just write YAML. Nobody wants to write YAML. It's implementation details. As a developer, you have one flow in mind, and that's writing code. There's no point in saying, oh, well, developers will just write the YAML, right? No, not at all. Empower your developers. This is my kind of phrase. You got it right. I don't know what he was on, but developers. They are the fundamental aspect of making change in your organization at the end of the day. Now, this doesn't mean that we just chucked again the YAML to the developers or the JSON to the developers. We still build compelling tooling to implement that, and we, as DevOps SRE quality, we are specialists and help developers kind of figure out their path to getting their service out to the world. We create open tooling. We support an open source product called Formats. We define Spinnaker pipelines as code. So what does that look? Developers can define things like application details. They can define the auto-scaling groups, how much to scale up and down. They can develop load balancing. There's no team to create load balancers. It's all done through tooling. What ports do you want to expose? What SSL certificate do you want on that? What's the health check? You control over layer 4 and layer 7 firewalls. That means developers can expose or reduce the access to the application. No longer it's talking back to other developers. Hey, can you whitelist service product to call me at port 80? Sure. That was a base conversation between two developers and two development organizations. Integration of quality into the pipeline. Reckless? Potentially, but when you think about it every major outage that's kind of occurred. I would argue that a good chunk of them have typically been, well, what changed? Oh, a deployment. Okay, is the developer online? Oh no, okay, it's Saturday? Okay, well then, whose dog is that? Let's roll back the change, right? Rolling back your changes typically is the most common aspect when something goes wrong. But I always argue, did that fix ever go back? Is that fix still deprioritized because that other customer feature took priority? Instead, if you can make delivery to the cloud that fast, you can solve that aspect right there and then and move on. So this is kind of the part where, this is great, this is all the demos and stuff, but there's no way to do this in production, right? Well, yes, we do. So we implement safe developer guardrails. The developers are never at fault if they break off the system because we as DevOps have to provide the tooling and the flow for them to deploy, right? We ultimately give them this guardrail of, you can do this, but you can't do that. But we can relax it in time, right, as people with expertise. But then there's always things like, especially in elevated environments, well, I wrote the code, right? And what if I'm trying to, fraction a penny off of every transaction? The auditors will never allow that. Well, if you look at the requirements, a committer, the person deploying the software can't be the same person who wrote the software. In this environment, just add an audit check step. Is the person who clicked the yes button in that pipeline the same person who wrote that software? If so, cancel the deployment. Otherwise, allow it through. All changes must be audited and tracked. Great, we totally agree. Everything is audited and tracked. We're putting it into Jira and tracking it, and you can even go down to commit level. All changes must be tested and verified. You have a quality step. No longer do you have to kind of schedule these, well, I guess we could run a regression every Tuesday, and every Friday we can do a security scan. Have them part of the pipeline. Have them run asynchronously. Run it as much as you need to generate the confidence in that these deployments are optimally delivering value for your business. Answer questions with data. You're only as good as your data. If you're going to abstract away any of the core tooling, you need to offer your developers metrics and tooling. You can't just expect them to go to prod without having visibility. They need their logs. They need their metrics. Give them those tools to essentially view and debug their services. Again, going back to the phrase I said earlier, if you can observe something, it can be described. If it can be described, it can be automated. And the market is trending to this concept of data ops. You should talk to Wayne about data ops at Redbox. So does this work? For us, it's been a tremendous success. We rolled out the pipeline earlier this year, had a few beta candidates, but we have developers deploying over 500 times a month to production. To all our various environments, of which all these are owned and operated by developers, which is actually pretty wicked cool. So in summary, Kubernetes is built from the ground up for microservices, ideally stateless. You could do stateful workloads if you want, but a lot of things kind of cater towards the stateless market. It's not going to solve your issues magically. I'm sorry. I hate to break that to you. Your CTO might be saying, we need to do this Kubernetes thing. Seriously think about it. Have a good planning session. Figure out what that means for your business. Using something like a service mesh can supercharge your Kubernetes and reduce some of that burden of logic when you handle a distributed environment. Spinnaker can wrap the complexities around continuous delivery to Kubernetes while giving you that global view across your entire application stack, essentially allowing you to deliver your way, your company's way. Empower your developers to make change, but don't burden them with implementation details. No one wants to write YAML. Build and support your developers with common tooling as well. So this is just kind of my thank yous. I do have to thank a lot of the open source community. A lot of the things that we as organizations, and especially in the Chicagoland market, is based on open source. If you aren't leveraging open source, you probably most likely are leveraging open source. Consider contributing back. Look at things like the Cloud Native Foundation, Continuous Delivery Foundation. They have an awesome map of services. Robert showed this earlier, but you can take this apart and find almost any tool you want that's open source available for you to contribute and support as well and use in your day-to-day. If you like Spinnaker, want to learn more about it, you're going to KubeCon. There's a Spinnaker Summit happening at the end of before this KubeCon this year. Come join us. We're always happy to see more in the community. We love new members, and we're always welcome. We have a public Slack. We always help debug and get you all squared away too. If you want to know a little bit about more around Redbox, we have a tech blog. We talk a little bit more around our open data architecture there, and kind of the service outages and things that we kind of learned over time. Check us out. But with that, that's my whirlwind tour around Kubernetes and Istio and software delivery into Kubernetes. With 4 minutes over. Oops. Thank you everybody for coming to my talk. For the sake of time, I can answer questions now, but I'm sure everyone wants to grab a beer or something, so if they're doing something like that outside, I'll be around the whole rest of the evening. Please, by all means, feel free to come up and talk to me, and I'll be happy to answer any questions. Thank you again, everybody.
I don't know that much about Kubernetes, just kind of started learning about it. But the one thing that I kind of thought I knew is you do have to YAML. You're just making a joke. Isn't that what your main thing is?
So you 100% need to. You 100% need to. But find commonalities across the YAML. If you have multiple services, that you probably do.
Right.
Look at those YAML files, and you're probably going to identify some key values that are probably consistent. Replicas maybe defaults to 3 deployments, right?
Right.
Every service needs a service file, or service definition, most likely, right?
Right, right.
However, the only difference between it is usually the name and maybe the ports. So instead, figure out a way to automate around that. Like maybe like using something like Customize that I showed earlier in the slide deck to templatize that YAML and auto-generate it at deployment time.
Yeah, came in late. One tiny little stupid question.
No,
Can you
it's not
write
stupid question.
a YAML? Some of them have YAML, some of them have YML. The things to
Lazy
process just don't get it.
That doesn't matter.
Just don't get it.
Yeah, it doesn't matter. As long as you have it to the valid spec, you're good. Yeah.
I couldn't capture some of the slides. Is there any way that you can actually send the slide out?
If you have Twitter, I'm going to be tweeting these slides out right now, actually.
Oh, really?
Yep. So if you want, follow me on Twitter. You don't have to have an account. Just go to my Twitter. I'll share this entire slide deck out that way.
Oh, really?
Mm-hmm. And any questions you may have or anything, please feel free to reach out, even after the talk. Happy to help out. Thank you again for coming.
Joe, great talk. Where are you gonna get the slides now?
Huh? Twitter. I'm gonna put them on Twitter.
Cool.
Yeah. I think it was a little too much. A little too much. Now having presented it, it's a little too much content. I think I should. It's really 3 talks. The first talk is the history of computing. The second talk is Istio and Kubernetes, and the third, actually there's 4 talks. Delivery into Kubernetes using Spinnaker, and then ultimately the whole culture shift around DevOps using Kubernetes.
Cool. No, that's all good.
I'll share it. I'm going to share them on Twitter. Do you have my Twitter? If you want to take that down, that's my Twitter handle. I'm going to publish the slides here actually once I get off the screen.
Hello.
Hello.
So my team is very shy because we heard you say don't make people write YAML,
Yep.
and that's what we do.
We love to make people write YAML.
It's okay.
I mean, it's
It
like a
gets very
30-line file.
repetitive. It gets very, very repetitive. That's my argument.
And we give them the structure, it's just when they need to make changes to their application, then they have to change the YAML file.
No, so generally speaking, the first thing to look at is Terraparty YAML file. Majority of it is probably the same. At least the very same, the metadata may be similar, save the keys, the actual values in those keys. Figure out a way to generate those dynamically, right? And also give the ability to override those if you need to. Writing YAML is fine, but copying service version 1, pod replicas 3 over and over and over again is repetitive, and it's gonna be error prone. Someone's gonna fudge it up eventually. And instead, kind of give away, like for example, I showed the tool Customize, where you provide a stable base. Majority of developers don't care that when they commit, that it's 3 or 4 servers in development, right? They just want somewhere that they can hit and view their application and test it, right? that's where like things like customize come into play. Now, when you go into production, things can get a little bit more complex, obviously.
Yeah.
But like giving a full-blown YAML,
How do you think we could abstract that from developers? The YAML writing process, is that something that we could create some kind of a front end for that?
no need to. There's no need. Oh, sorry.
No
I'm
need to
getting
do
in your
that.
way.